This paper, educational paper, speaks about teaching atmospheric physics using Arduino based tools, using what's called project based learning in STEM education. So as example, in the capstone projects in the semesters, students are generally sensitive to and curious about the changes in their environment and spatial phenomena. Therefore, the science teacher should find the appropriate methods to explain these natural phenomena. This paper is based on project and experiments. Introduction. The Arduino study group is part of a school curriculum pilot development project designed to raise the students' interest and attitudes towards learning. The Arduino Learning Group, Arduino Group. The Arduino project, like problem-based learning or project-based learning, a measurement project based on an Arduino microcontroller allows to determine the composition of the atmosphere with an appropriate sensor, or to construct a mini station that continuously measures atmospheric characteristics. Same time, students can gain new knowledge and skills about circuits, sensors, circuits laws, and data processing techniques. Basics of electrical circuits building and design. They can know about ideal gases laws. The ultimate purpose of this program was to build a mini weather station to monitor atmospheric parameters. Pedagogical approach. Project-based learning method and problem-based learning method. The first step was to organize the Arduino working subgroups. The first subgroup studied the theoretical background of the description of the weather and climate. All things and the parameters such as pressure, relative humidity, temperature, and the thermodynamics laws of ideal gases. The second subgroup are responsible of what the wind direction and strength depend on, and the relationship between humidity and temperature or pressure fluctuations. At the same time, how do we apply the laws of the thermodynamics to describe the biological process or to explain the weather phenomena? The third subgroup has responsibility about the tasks was to find out how sensors measure pressure, temperature, light intensity, relative humidity, and amount of precipitation. So they needed to answer questions like, how could you design a measuring device? Or how could you measure pressure, temperature, relative humidity, light intensity with sensors? How a circuit with sensors could be designed? All these great questions. The fourth subgroup will speak about or study about techniques of designing and building circuits, circuit laws, operating rules of passive and active circuit elements, and low voltage circuit were studied. So based on their results, a flow chart was designed and printed circuit models were assembled for testing. Based on this, the circuit is constructed in cooperation with the third team. The fifth subgroup, which is the IT group, applied the knowledge gained during the IT lessons in a real environment. First of all, they got acquainted with the operation of the Arduino microcontroller and tested the sample programs. Using the given examples, they wrote their own programs for controlling the unit and then for data processing. In the first phase, each subgroup had 1 month to develop and solve the assigned tasks, following a predefined research plan. Each subgroup first carries out a self-equalitative presentation of their work on the project. The final step is to write a final test that evaluates the level of additional knowledge and skills gained throughout the project. Construction of many meteorological stations. Throughout the learning process, the teacher enriches the work of the groups with theoretical knowledge, helps to systemize, expand them, correct misinformation, and advise on further research. The Arduino measuring device. The project presented above is ideal for enriching and deepening the knowledge required in the 9th and 8th grade physics classes. So, moreover, the parameters they studied about or will study about, there will be light spectrum, ultraviolet, and infrared components. So, here, if the student is able to explain and apply the gained knowledge on the following, which are the physical quantities that determine the weather? How can thermodynamics laws be used to describe atmospheric phenomena or biological process? So the third is the dependence of weather on the geographical location. And the fourth question, how should an electrical circuit be designed? And the fifth one, to build of a well-functioning measuring mini weather station. And sixth, to write a proper command software and data analysis. So simple sensors are looked at, the sheets are consulted together with their application guides that are provided by the manufacturer. Figure 1, the following figure. The electric distance between armatures and its surface affecting electrical capacitance. This is example. So this is the sensors, and this is the types of the sensors, and here the interface in the electronic board, and here the output will be ISDN, SCDO, SCK, SCV. So we have the data sheet, which is in the C figure. We have, this is the logic operations or diagrammatic operation diagram, which shows the processes, what will be happening inside, and this is the electronic board of sensors. The Arduino microcontroller turned to be challenging for every student at the science club. So how to apply power supply, how do the analog and digital benzene, and how to connect an appropriate sensor to the chip. So here we have the figures of the building the sensors. Building هنا Arduino Uno are 3 pins, number A, and figures B, building the sensors for testing module on breadboard with LCD display. And here Arduino is not only a simple circuit element but a microcontroller that commands the operations of the connected sensors and devices. After the technical teams, which is number 4 and number 5 sub programs, select the appropriate sensors, power supplies, connecting wires and tools, and prototypes of the measuring stations are prepared, and the control program for the testing is uploaded for testing. Once the errors, maybe after we operate these programs and with this Arduino, we can find some errors. Once the errors identified during the test have been corrected, and it worked suitably. PCB design for the weather station, binary coded decimal number, binary coded D. We not only create control programs for the stations, but also data processing assistance, graph with Excel or Python, animation, simulations, etc. A mini meteorological station is already built for the school, which uploads the measured data to a web page where it is accessible to the public. Note, only does this page display daily. measurement data by hour, but older measurements can also be downloaded from the archive. The statistics give the maximum and minimum pressure, temperature, and humidity for the selected time interval, as well as the mean value for the period figure 4b. And this way, one can easily use the acquired data in geography lesson where students study, whether in the region, in the biology, or in a biology lesson where they follow plant development, or even in masses and economics lesson where it comes to statistical data processing. Frequent use of data is also evident from the number of web as follow-up of the program. It is planned to work with other schools to develop a network of measuring stations, measuring stations, and this will help students to better understand the original characteristics of the weather and teach them to cooperate in various projects. In conclusion, the voice primary aim of the mini meteorological station building project is to provide students with an efficient learning environment and conditions with innovative methods and a cross-circular approach. Active learning program opportunities, task discovery, curiosity, task or project oriented methods. Students who participated in the science club have more in-depth knowledge than their classmates who did not join the science club. Thank you for watching this video. If there is any problem, don't hesitate to write your comment and I will reply you in a comment or in a video. Moreover, in this video, these concepts are maybe a symbol of this project can be taught to 6th grade or more difficult at solving abstract problems as a high school student, and they are more confident to find connection between phenomena learned in different lessons and work more collaborative in teams than others. Another aim of the project was to teach students working methods and practical skills that could not be developed in the traditional classroom activity. Working in groups around the different tasks, each student can evolve, use creativity and individual ideas to achieve a common goal that he or she could hardly have solved alone. Thanks for watching this video.